few folks sit around. I think the acoustics is very comparable to the era we are in quantum computing. It's the noisy intermediate, the scale era. But today, what I would like to do is talk with you about the final frontier on sovereignty, superiority, and security, because I think that's what quantum computing is about. Why is everybody so excited about quantum computing? It is because the exponential speed up in compute power. I think it's the only business where the underlying trend actually is the exponential function. Sooner or later, everything which has to do with big data analytics will be outperformed by the exponential function. That's and I think we are standing on the shoulders of giants here. The basic quantum mechanical principles are more than 100 years or almost 100 years old. Brilliant minds like Schrödinger, Einstein, Planck, and Heisenberg laid the foundations of early quantum physics. Today we know how to build a machine using those principles, entanglement and superposition, to create a machine with such great potential. That's why it is a global race for supremacy. Currently, I think it's China who might be leading the pack a little bit, followed by the US, and Europe tries to compete. And if I see the kind of great, vivid ecosystem here, I'm very full of hope that we can make it also in this big concert. We all know that the quantum hardware isn't yet there. The scalability of the quantum chips is not given yet. We cannot really unlock business performance using native quantum chips so far. Is this kind of a problem? Well, it's quite typical. The quantum computing is like any other deep tech discipline following the Gartner hype cycle. After a phase of excitement, the technology cannot yet deliver. With us, it's the NISQ era, the NISQ valley, before the technology reaches a plateau of large-scale productivity. Nevertheless, the performance opportunity is massive. Regardless of what source you take, it's $1 trillion market opportunity kicking in very soon, and I think that makes us all exciting. The flip side of the coin is the security threat. The Q-day comes nearer. The threat from quantum computers hacking any classical encryption code comes nearer every day. So what do we do with this? Do we have to wait now the next few years until we can do something meaningful with quantum? Actually, no. We can start with substantial business applications already today. There is a way to bridge the NISQ gap, and that way clearly is hybrid quantum computing. Hybrid meaning mixing the best of breed of classical supercomputing and early available quantum computing on the software as well as on the hardware side. By the way, this is also a long-term trend. We will always mix classical computing and quantum computing also in the long-term future. But short-term, it means that we simulate the qubits, we simulate the quantum hardware on classical HPC environments to create the underground, the platform to run our quantum software, our quantum algorithms, which we can write today on it. And such hybrid techniques actually enable us to unlock some of the quantum potential already today. It was recently the McKinsey Global Quantum Study later this year, which showed the outperformance this can create. It was Terra Quantum's QMWare's benchmarking studies who showed that if we select the use cases wisely, the classical big data analytics use cases, we can, with hybrid approaches, create an outperformance not only vis-a-vis today's native QPUs, and that will be valid for a few more years, but we can also beat best-in-class classical HPC implementations. And that's where the beef is. That's what you can transform in real business performance already today. With e.g. what we did, we can create more than 15 times faster optimizations and more accurate results. We can have 30% more accuracy in machine learning with less data, and up to 200 times faster simulations. And that, again, you can use to create an outperformance today. It was, I don't know who read it, recently also in the Wall Street Journal, which said, those, massive GPU infrastructures built following the Gen AI hype are kind of underserved. We need more applications to create a good ROI on those hardware infrastructures, and quantum actually can do it in that hybrid approach. Just to show you what is possible today already with such hybrid techniques, e.g. we work for a European investment bank with a 400 billion so-called collateral portfolio. It's a mission-critical optimization algorithm within investment banking and portfolio optimization. And transferring that into the quantum space, running it on such hybrid environments, in particular a 42 logical qubit simulator, we create 240 mil in annual recurring cost savings. That's what we can create today. Those 6 basis points on the portfolio can be 20, 30 basis points going forward with more mature native hardware. But why wait for this if we can get this, the 240 mil, already today? Another case, we work for Thales, European aerospace company. They have Earth observation satellites crossing the Earth, and they get a lot of picture requests, and their task is to maximize revenue, to select the right picture requests to maximize the revenue whilst they make their turn around the world. What we did with a quantum enhanced satellite mission planning tool is, if you accumulate it for the whole Earth observation satellite market, create a 6 billion additional revenue opportunity, which can be captured today. I'd like to quickly also turn towards AI, because there's a big hype around Gen AI, all these tools, large language models, and the discussion about whether they are dangerous or whether they are actually a threat to humanity. I would argue no, definitely not. From a quantum perspective, from a physics perspective, I think those Gen AI tools, although they serve a great purpose and can deliver value, they are definitely not intelligent. They are more or less stochastic parrots. Yeah, there is deterministic outcome of what you put in. There is full predictability. There is nothing which I would call intelligent or creative. On the other hand, QAI, AI on a quantum computer, is totally different. If you are excited about classical AI, I think you should fasten your seatbelts on QAI, as the underlying quantum physics in its single event character is non-deterministic, non-causal, non-local. I think the quantum randomness which comes in, this could really lead to something which you potentially could call creative or intelligent. Let's move from the performance opportunity towards the security threat. Today we count on end-to-end security, right? It's used in adverts, but code breaking was always a tool of malicious actors to also propel the industry forwards. It's a malicious motivator in its evolution of security codes, and we all know that every classical encryption code will be hacked by future quantum computers of enough size. And we know that no code will be safe, regardless of whether it's symmetric or asymmetric encryption. AES, for instance, which is used within your WhatsApp, or SHA for Bitcoin or other crypto assets. They are not quantum safe. They will be hacked. The hash function will be reversed sooner or later with a future quantum machine. The US Homeland Security says or predicts that around 2030 that Q day has come and the data are not safe anymore. And that's a big issue. You could argue, if you are a CISO of an organization, well, that's still some years down the road. Why should I worry today? I have other topics. But the situation is that we have more and more malicious actors who store classically encrypted data today to decipher them with a future quantum machine. And that's why you have to act now. The quantum encrypted protocols have to be there and implemented before the hardware threat kicks in. And NIST structures that process towards a quantum secure communication future in 2 steps. The first one, PQC, post-quantum cryptography, which is more or less just an advancement of classical encryption, longer keys, etc. The second step really is, I'd say, the Champions League for quantum, which is true QKD protocols, quantum key distribution protocols, which use quantum entanglement. And I'm very happy to say that us, Terra Quantum, we own the world record in long distance QKD, which can be implemented today via existing optical fiber infrastructure through our novel approach, and you can read it also in Nature. It's possible to quantum secure the network, the optical fiber network, passing distances in that world record is 1,032 kilometers, beating the Chinese by 30 kilometers, but with a key generation rate which is 10,000 times faster than the work of the Chinese. This one is really practically implementable today, and you don't need quantum repeaters for this, you just need classical optical amplifiers, and that makes it very attractive. We can enter into a quantum secure communication future already today. And I would like to sum up the presentation here. We all know, and we are all strong ambassadors, I think, in this audience here, quantum tech is the final frontier, and it's about to collaborate on the potential opportunities, but also tackle the risk. And if I can draw kind of a picture of the future, I think it would be great that we all support European sovereignty in that game. I strongly believe that Europe has to own the whole value chain from quantum hardware towards quantum software, not to become dependent on any of these value chain elements from other regions. The way forward, I think, leads towards hybrid quantum data centers. The hybrid approach is the way forward, as we will have to wait for native quantum chips the next foreseeable future to really create outperformance. The hybrid way makes it possible to unlock some of the potential today, and I don't know how you think it. If you deal with customers and you are, a quantum startup, I think the time is over where you can just go to your target clients and make a research study about quantum. They want to see business performance today, or would wait until you come back and can deliver this. Therefore, I think this is the way forward. And last but not least, I think all actors, and it's a huge market, who deal with confidential data, which they transport digitally, have to prepare for the Q day starting today. We don't know when the threat actually kicks in. The next day, the quantum hardware is available, and not all actors are totally transparent. The next day, you would be hacked. Therefore, prepare for a quantum secure future. And there are ways on PQC, but also already in the QKD space, to protect yourself and your data. With this, I would like to close it here. I think we all work on, in a way, quantum as a service, like software as a service, to make quantum applicable and usable for our target audience very easily. And I see a great future where this ecosystem comes together and every piece of the value chain comes together to form a real end-to-end quantum as a service offering which makes it feasible really also in the practical day-to-day life to unlock the quantum potential. Thank you very much.
Thank you so much. And we have a little bit more time, so maybe we have some questions in the audience.
That would be great to facilitate a dialogue.
So if there's something you want to ask, please raise your hands. Tiana will help us with the mic. Or you maybe explained everything so well that there are no
but
more
it would be
questions
great
in
to
the
get
room.
actually into a dialogue, right? We are
There
all
is
here.
one. There is
Everybody
one.
has to do something with quantum, so it's great to share opinions.
Yeah, thank you very much, Dr. Flitsch, for that nice introduction into what you're doing and the value that can be created today. I think
Daniel, can you?
No,
I think you pointed out very well that we should stop talking about use and start talking about business cases for quantum. And this is kind of the angle from my question. Which sector, from your perspective, would be affected first and should be maybe reach real quantum advantage, like not only in single particular use cases, but being implemented in algorithms and so on, maybe during the next 5 years?
Yeah, very good question. Actually, it's a question also I received from some of my investors who said when we had that great algorithm which does portfolio optimization for investment banks, Markus and management team, you have to focus only on financial services now, only investment banking. You go from Goldman to X and Y and Z and implement it all over the place. And I said, no, we don't do that, because the underlying algorithm is so much broader, serving across industries. We have a hybrid quantum neural network, right? This serves for better image recognition, to name another example. So we can use this for, talk to the car industry on autonomous driving, but we can use it for cancer detection as well, right? Or for dangerous missions for robots. So the underlying algos, I think, are so strong over arcing a variety of industries that I would strongly recommend not to focus on a particular industry. We see use cases and have identified 150 plus use cases across industries where we can deliver value today, but if I would be forced to kind of prioritize my capacities, I'd say definitely banking, financial services, because it's a lot about portfolio optimization, risk simulation, and all that stuff. So therefore, definitely, I'd say financial services. And then there are some other industries which also have a great potential, but to face the reality, it's hard to tackle them today with the hybrid approach. Take drug simulation, pharma. A lot of that stuff, you really need more powerful QPUs. But there is enough which you can tackle today. We work for, as I said, aerospace, automotive, financial services, chemistry. So a lot, I think a lot which we can do already today. Thank you.
Mark,